Hello students, this is Dr. Singhal, PhD from Computer Science Department in El Camino College in California. We're going to talk about insert function of a linked list class. Okay, let me show you the code for insert function first and how it will be used. So let's go to code blocks where my code is sitting. If you go here, this is the insert function code. That function gets a value called val, and then this is just one line code. To the node class constructor, the value is passed, and whatever value of the head node head pointer pointing whichever node is pointing to, whatever value is stored in the next field, that's actually passed to the node class constructor, and return value is stored back again into the next field of whichever node head happens to be pointing to. Okay, obviously to use this code you're going to have a linked list object first, and you can do that through a loop, but basically you're going to do a linked list constructor call here, and then through a loop we are getting a value from the user and we are calling the insert function to add it. Okay, so let's see how this constructor works. So if we go back to our PowerPoint, this is the node class constructor, of course. That data field is set to val, and next field, which is a pointer of node type, set to this value whichever pointer is being passed here. And linked list class constructor is very simple, one line code. That head pointer to the head node, again we are not calling, head is not the name of the first node, head is a pointer to the first node. Okay, just remember that. So this constructor calls create a dummy node which has a which is not a number in the data field, and null ptr in the next pointer field. Okay, so when this constructor is called, basically let's go back to the node class constructor. The data field gets a, next field gets null ptr, this value. When that happens, the linked list looks like this. Okay, it creates a dummy head node. So first node is actually dummy head, which is not real data. It's just the node that we use in order to build rest of the linked list. Okay, and if address of that node is 100, then that address gets stored into the pointer to the head node, or pointer that is called a head by the name head. Okay. Well, let's see if we want to add some real nodes which has the user data. So assume this is the insert function again. Insert function gets a value called val, and assume val is 5. So when this one line code in the insert function will be executed, there are two parts to it. Okay, I already jumped one. This thing is very sensitive for some reason. So first is that right side of this expression has to be done, which means new node has to be created. And this new node creation has two parts. The val, which is 5. So in the data field we'll put 5. New will return a memory address. Let's say memory address is 200. And then the next field will have head arrow next. Well, right now next field of wherever head pointer is pointing to is null ptr, so we're going to store that here, and that's how the right side of the expression creates this node. So this is the node creation process, and every time we call insert function we'll go through this two-step process. First step is the node creation, which is the right side of this entire expression. Okay, second part of this will be that once new has returned a pointer address, it will be stored in that node, which is the next field to which head pointer is pointing to. And the meaning of that is that this 200 should really be stored here in the linkage part of this. So in link formation process, uh, the address returned here is stored in the next field of a node where head pointer is pointing to, which was this one. This is head pointer pointing here. Next field is this one. So when that 200, that new node had the address, which is when it's stored in the next field, we form the first user inputted linked list data node. Okay, and then we just repeat the process as I showed the code earlier. You will do that through a loop, and we just have two steps every time: the node creation and the link formation. Node creation and the link formation. So I'm going to show two more examples of that. So this is formed now, and in the process of showing that these things here, I may have to move them around a little bit, but nevertheless the linked list will be there. Okay, so assume that value is 10. So again, there are two steps. That first, the right side of this expression will be done, which is new node. So value is 10, so 10 will go into the data field. Understand that head arrow next right now has 200, so that's copied here. Okay, and then as soon as that happens, this previous node that had 5, that gets linked to this new node that got created. Okay, so that means any new node that is being created is being added after the dummy node, not at the tail of the list. So this 200 that was there gets copied here in the new node. And meaning of copy is that as soon as you do that, a link has to form. If this address is 200, this node's address stored is 200, node's address is 200. That means there's a link here actually. Okay, and then the next part is the link formation. The new will return an address of 300, and that has to be stored in the next field of that node to which head is pointing to. So that means this linkage will be made, and that's exactly in the link formation part. When address returned by the new is stored in head arrow next, then that happens actually. Okay, so we added a one more node, and it will always be, every new node will be added as after the dummy head. In a way you can say it's in the front of the list, not at the rear of the list, but front of the list. Okay, we'll show one more node so that whole concept become clear to you. So just remember this linked list the way it is right now. So next time, let's say we add a value of 6. Okay, so 6 goes here, head arrow next at 300. So 300 will be copied here in this new node. This is the new node which has 6 in it. As soon as that is done, a linkage is made, and then the return value, let's say this node has an address of 400, should be copied into the next field of where head is pointing to. So it's pointing to here, so 400 is stored there. Okay, and this is the node creation. Actually, I'm showing in 2 steps, so maybe I shouldn't have this arrow here. That means my next slide will be identical. Oh, actually I didn't even have next slide. All right, so here I've shown both processes in one slide, the node creation and link formation. Okay, so conclusion is this, that every new node is added as a front node after the dummy node. Linked list will be built in the order reverse of order of data entry. First node will be the tail node of the linked list, and last node will be at the front but after the dummy node. Now some of you say, okay, I want to create linked list in a way that order of data entry from front to back is preserved, just like a queue. Although in Q you can do the removal, but here you're not doing that. So in Q you always add to the rear. So you say, okay, I'm just want to have it behave like a Q. So it's always added to the tail. Well, you could do that, but extra coding is required because in that case, what you would need to do is, let's say this is already my built linked list, and I always want to add at the end. Well, then you need a pointer, extra pointer, that'll traverse the linked list up to, let's see, up to here, and then whatever pointer there is, uh, that pointer arrow next should be creating the new node. So you'll need one loop to traverse the linked list, go all the way to the end, and then add the node there. So it can be done. You can write a function called uh, add rear. It will always add to the rear of the linked list. So it's not very hard to do. So think about that as an exercise. You should do that. I have an insert function that I gave you, whose code is here, which always adds the node in the front. But you should write a function called insert rear, which takes a value and always insert at the end. And that way you can have both functions, and you can use either one depending upon the kind of need that you might have. So you might say, okay, where would I need this insert rear? Well, one option may be that you already have a sorted list of some kind stored in some other structure, maybe array or something, and you want to create exact same order in a linked list from front to back. Okay, well, in that case, unless you add at the tail all the time, your linked list will be reversed. Okay, so that's the kind of situation you may need it, and you could do that. So go ahead and write a function called insert rear. So it'll be insert rear, it'll take int val, but this code will not be sufficient. You have to write a loop so that you traverse the list and go all the way to the end, and basically add the node always to the tail. Okay, so you should do that and confirm it that it works. This was shown in the class video. PowerPoint was not shown, but I did that on the board. So this is for those who need a refresher. So please watch this video for that purpose. Okay, once again, this is Dr. Singhal, Computer Science Department, El Camino College, California. Thank you so much.